December 18th, 1944. 11:04 a.m. Eastern France. A single gun fires. One shot. One trigger pull. One tungsten core traveling faster than the speed of sound crosses 2,000 yards of frozen air and punches straight through 100 millimeters of the most feared armor in World War II like it was tinfoil. The Tiger tank, the machine that had dominated every battlefield from North Africa to the Eastern Front for 3 brutal years, erupts in smoke. 2 men die in seconds. The German crew that had survived 17 months of continuous combat is gone before they can even process what just happened, and the gun that killed them. It belonged to a vehicle so lightly armored that German training manuals literally classified it as not survivable under direct fire. This is the story of how American metallurgy secretly rewrote the rules of armored warfare and how the most feared tank in history stopped being invincible, not because of a better tank, but because of a single revolutionary bullet. If you want to know how this impossible shot happened, how a stripped-down American hot rod killed 2 Tigers in 14 minutes at ranges where they were supposed to be completely untouchable, then hit subscribe, turn on notifications, and stay with us. Every week we dig into the military secrets, forgotten breakthroughs, and incredible human stories that change the course of history. You don't want to miss what's coming. But first, let's understand exactly why what happened on December 18th, 1944 should have been impossible. By late 1944, the Tiger I heavy tank had built a reputation that bordered on mythological. And it wasn't propaganda. It was math. Cold, brutal, battlefield-proven math. The Tiger mounted an 88mm gun, originally designed as an anti-aircraft weapon that could penetrate the frontal armor of any Allied tank in existence at ranges exceeding 2,000 meters. The Sherman, the Churchill, the T-34. It didn't matter. The 88mm gun reached out and killed them all before they could even get close enough to threaten the Tiger in return. And the Tiger's own armor. 100 millimeters of face-hardened steel on the frontal hull. Angled, layered, and hardened through a metallurgical process that made conventional armor-piercing shells shatter on impact rather than penetrate. By 1944, German armored doctrine had built an entire tactical philosophy around this asymmetry. Engage at long range, 1,500 meters, 2,000 meters. Let the 88mm gun do its work from distances where Allied guns simply could not threaten the Tiger in return. Then withdraw before the enemy could close distance and use numbers to overwhelm. This wasn't theory. This was a doctrine written in the burning wreckage of hundreds of Allied tanks from Tunisia to Normandy. Feldwebel Klaus Brainer understood this doctrine better than almost anyone on the Western Front. At 34 years old, he had commanded Tiger 214 of Heavy Panzer Battalion, 506 through 17 months of continuous combat. The Eastern Front, Normandy, the brutal withdrawal across France, and now the defense of the German border itself. He had survived not through luck, but through absolute mastery of the Tiger's tactical advantages. His gunner, Otto Zimmer, had fired the 88mm gun in combat 114 times. He kept count in a small notebook. 67 confirmed kills, 23 probable. Zimmer knew the precise aim points for every Allied tank type at every combat range. He knew exactly to the meter where safety ended and danger began. Against American M4. Sherman tanks with the standard 75mm gun, the safety range was 1,800 meters. Beyond that distance, Sherman rounds either fell short or simply bounced off the Tiger's frontal armor without penetrating. Against the upgraded Sherman with a 76mm gun, a weapon with significantly higher velocity, the safety range dropped to approximately 1,200 meters frontally. The 76mm could theoretically threaten Tiger armor at closer ranges, but only under nearly perfect 90-degree impact conditions. In practice, Tigers could engage Sherman's 76mm tanks from 1,500 meters with virtual impunity. Then there was the M18 Hellcat. German intelligence had picked up on this new American tank destroyer by August and September of 1944. The reports were almost contradictory. On one hand, the M18 was described as extremely dangerous. the fastest tracked armored vehicle of the entire war, capable of 55 miles per hour on roads. A vehicle that could appear from nowhere, strike, and disappear before German crews could even react. On the other hand, those same intelligence reports emphasized one critical weakness that made the Hellcat fundamentally non-threatening in direct combat. Its armor was only 1 inch thick on the turret front, less on the hull. The tactical assessment was blunt and confident. The M18 depended entirely on mobility and ambush. In any direct engagement against heavy German armor, it was not expected to survive. And the gun, a 76mm M1A1, essentially the same weapon as the Sherman 76mm, could only threaten Tiger frontal armor at ranges under 800 yards, and only with precise shot placement against specific weak points. Klaus Brenner had personally validated this doctrine twice. In September 1944, near the Moselle River, his crew had engaged and destroyed 2 M18 Hellcats, exactly as doctrine predicted. The first died at 1,400 meters, a single 88mm round through the hull, instant catastrophic explosion. The second had actually used terrain skillfully enough to approach within 900 meters before exposing itself. Zimmer killed it with 1 shot through the thin turret. 3 crew members bailed out and survived. Brenner had felt no particular anxiety about either engagement. The Hellcat was fast, but speed without armor was suicide against German guns. The doctrine held. The math was correct. Everything was exactly as it should be. By early December 1944, Heavy Panzer Battalion 506 had been pulled from the line for maintenance and preparation for the upcoming Ardennes offensive, what history would later call the Battle of the Bulge. Brenner's crew used the brief respite to perform extensive work on Tiger 214. The Maybach HL230 engine received new spark plugs, fresh oil, and a complete inspection. The transmission, always the Tiger's mechanical weak point, was carefully serviced. The crew cleaned and inspected the 88mm gun, checked the optical sights, and conducted bore measurements to assess barrel wear. After 17 months of combat, some wear was measurable, but accuracy remained excellent out to 2,000 meters. Test fires at the company range confirmed it. During the training exercises, the company conducted tactical scenarios, simulating the expected conditions for the Ardennes attack. One exercise specifically addressed the M18 threat, positioning a captured American M10 tank destroyer as a proxy and running Tiger crews through engagement priorities against fast-moving American armor. The conclusion matched existing doctrine exactly. Engage at maximum practical range, 1,500 to 2,000 meters. Do not allow them to close distance. Their speed makes them dangerous at close range, but at extended range, the Tiger reigns supreme. No one in that briefing suggested that American tank destroyers now posed a credible threat at 2,000 yards. That possibility would have seemed like a violation of every lesson learned from 3 years of armored combat. What Klaus Brenner didn't know, what no German tanker on the Western Front knew, was that American ammunition technology had undergone a quiet, revolutionary transformation over the previous 6 months. And the men who created it weren't generals or famous scientists. The breakthrough came from engineers and metallurgists working in a proving ground in Massachusetts, solving a problem that most people had assumed was simply unsolvable. The problem was this German face-hardened armor was specifically designed to defeat conventional armor-piercing rounds. When a standard American M79 AP shell struck Tiger frontal armor at high velocity, the shell itself would often shatter on impact. The energy that should have driven a penetrating core through the steel instead dissipated explosively outward, the round breaking apart against the hardened face layer before it could reach the softer steel beneath. The armor was working exactly as designed, not just by being thick, but by being specifically engineered to destroy the projectiles sent against it. American engineers faced a fundamental dilemma. You could increase the velocity of the round, but if the projectile itself shattered on impact, more velocity just meant a faster explosion of fragments. The armor won every time. The solution came from a material that most people only knew from drill bits and cutting tools: tungsten carbide. Unlike hardened steel, tungsten carbide maintains its structural integrity even under the extreme impact forces generated when a high-velocity projectile meets face-hardened armor. It doesn't shatter. It doesn't deform catastrophically. It penetrates. Engineers at the Watertown Arsenal in Massachusetts developed a new armor-piercing round designated M93 HVAP, high-velocity armor-piercing. The design was elegant in its simplicity. A tungsten carbide core, smaller in diameter than the shell body, wrapped in a lightweight aluminum sabot, a carrier that falls away after the round leaves the barrel. This reduced air resistance dramatically and increased velocity by several hundred feet per second compared to standard ammunition. The result was a round that hit harder, held together on impact, and punched through face-hardened steel that had been stopping American shells for years. Field testing at Aberdeen Proving Ground in Maryland during June 1944 produced results that stunned the engineers running the trials. The M93 HVAP round, fired from the same 76mm M1A1 gun mounted on the M18 Hellcat, could penetrate Tiger frontal armor at ranges exceeding 1,500 yards under proper impact conditions. At 1,000 yards, penetration was nearly certain. At 2,000 yards, a range where German doctrine assumed absolute invulnerability, penetration was possible against the turret front or hull corners. The tungsten core changed everything. 50% better penetration at every range. The weapon that German intelligence had classified as marginally effective only at close range had become something else entirely: a potential Tiger killer. At ranges German crews had never considered dangerous. But here was the catch that shaped everything that followed. Tungsten was a strategic material desperately needed for machine tooling, cutting equipment, and a dozen other critical manufacturing processes. Production capacity for tungsten carbide rounds was severely limited. Each M93 HVAP shell required materials that could otherwise produce 50 conventional armor-piercing rounds. The Army made a hard decision. M93 HVAP would be issued only to tank destroyer battalions units specifically tasked with killing enemy armor. Sherman tank crews would continue using conventional ammunition, and even for tank destroyer units, HVAP was strictly rationed. Each M18 Hellcat received only 20 to 40 rounds out of a total ammunition load of 45 main gun shells. Crews were instructed clearly: use HVAP only against heavy German armor, Tigers and Panthers, and only when conventional ammunition proves inadequate. The first M93 HVAP rounds reached frontline units in France in August 1944. Distribution was gradual and uneven. German intelligence noticed something unusual happening with American tank destroyer effectiveness in September and October. After-action reports noted several incidents where American 76mm guns had achieved what seemed like impossible penetrations against Panther and Tiger armor at extended ranges. An incident on September 28 near Metz particularly troubled German analysts. An M18 had destroyed a Panther at an estimated 1,800 meters with a single shot through the turret front. Shell fragments recovered from inside the destroyed Panther showed unusual material properties. Denser than normal steel, an unusual gray-silver coloring. The investigating officer speculated about possible tungsten content but drew no definitive conclusions. A German intelligence summary, issued on November 12, 1944, acknowledged that American armor-piercing ammunition may have been improved using special hardening techniques or possibly tungsten additives. But the assessment then made a critical error, one that would cost German tankers their lives. It concluded that such improved ammunition appears in very limited quantities and does not fundamentally alter tactical engagement parameters. Existing doctrine remains valid. Klaus Briener read this summary at a tactical briefing on November 20th. The consensus among the Tiger commanders was that if the American ammunition improvements were real at all, They represented a marginal threat at best. Nobody suggested that American tank destroyers now posed a credible killing threat at 2,000 yards. What the German assessment had missed was the true magnitude of the improvement. Not a marginal upgrade, not a slight improvement in penetration. A 50% increase in penetration capability, enough to shift the entire engagement envelope from Tiger invulnerability to mutual lethality. At 2,000 yards properly aimed, an M18 Hellcat equipped with M93 HVAP ammunition could now kill a Tiger from the front. The Tiger could still kill the Hellcat at that range. The 88mm gun was as lethal as ever. But for the first time in 3 years of armored warfare in Europe, the engagement was no longer one-sided. The safety range had ceased to exist, and Klaus Brenner, commanding the same Tiger he had fought in for 17 months, protected by armor, he trusted with his life, was about to discover this fact in the most catastrophic way possible. December 18, 1944, 9:15 a.m. The morning fog hadn't lifted when Brenner received orders to conduct a reconnaissance patrol southwest of Prüm toward the American lines. 2 Tigers and 1 Panzer IV. Intelligence value only. Avoid decisive engagement. The real fight begins in 3 days. The patrol moved out through pine forest, the fog reducing visibility to under 400 meters. By 11 a.m., as the column emerged into more open terrain, rolling hills, winter-dead grass, scattered tree lines, the fog began to lift. Visibility improved to 1,500 meters, then further. Brenner halted on a ridge, scanned through binoculars. The landscape appeared empty. Quiet. Exactly what intelligence had predicted. Then, his radio operator, Bauer, reported faint American transmissions on tank destroyer frequencies. Close. Very close. And at 11:47 a.m., Zimmer's voice came over the intercom with the words that began 14 minutes that would change everything. Tank destroyer, southwest. Range 2,100 meters. Moving left to right along the tree line. Brenner swung his binoculars. There it was, low profile, small turret moving fast along the distant tree line before disappearing into cover. Unmistakably, an M18 Hellcat. At over 2,000 meters, Brenner felt no alarm. His doctrine was clear. His math was solid. His Tiger's frontal armor was impenetrable at that range. He was wrong. And in Part 2, we'll watch second by second as that single M18 hull-down on a frozen hillside lines up a shot that every German engineer, every intelligence officer, and every experienced panzer commander in the Wehrmacht would have called impossible. We'll see what happened inside Tiger II-14 when the tungsten-core arrived. And we'll follow the shockwave that one penetration sent all the way up to German high command 3 days before the largest German offensive of the entire Western Front was set to begin. Stay with us. The most important 14 minutes of Klaus Brenner's life are just getting started. December 18, 1944, 11:47 a.m. A frozen hillside outside Prüm, eastern France. Klaus Brenner watched through his binoculars as an M18 Hellcat, a vehicle German doctrine classified as non-survivable against heavy armor, settled into a hull-down position 2,000 meters away. His Tiger's frontal armor was 100 millimeters of face-hardened steel. His gunner had 67 confirmed kills. His doctrine was airtight. His math was perfect. He had 14 seconds left before everything he knew about armored warfare became obsolete. In Part 1, we watched American engineers at Watertown Arsenal quietly solve the unsolvable, a tungsten carbide core that didn't shatter on impact, wrapped in an aluminum sabot, that shed resistance mid-flight, producing a 50% improvement in penetration at every range. We watched those rounds reach frontline tank destroyer units in limited quantities through the fall of 1944. And we watched Klaus Brenner lead his patrol directly into an ambush he didn't recognize as an ambush because his intelligence told him the threat was impossible. Now the gun fires, and everything changes. Zimmer's voice came through the intercom at 11:49 a.m. calm, despite what he was seeing. He's aiming directly at us, Herr Feldwebel. Has been for 30 seconds. Why isn't he firing? Brenner kept his binoculars fixed on the M18's position on that distant hillock. The American gun was traversed directly at Tiger 214, 2,000 meters, standard 76mm ammunition, frontal armor. The math said this was not a dangerous situation. The math said hold position. Wait for the shot, destroy the Hellcat the moment it reveals its position definitively. Steady, Brenner said. At this range his gun cannot penetrate. When he fires, Zimmer destroys him immediately. Bauer, the radio operator, spoke quietly. Something feels wrong, Herr Feldwebel. Brenner almost responded. Almost told Bauer that feelings didn't penetrate 100 millimeters of face-hardened steel. Almost explained the mathematics one more time. The M18 fired. Brenner saw the muzzle flash through his binoculars at the precise instant the tungsten carbide core of an M93 HVAP round. Traveling at over 2,800 feet per second after crossing 2,000 meters of frozen air, struck Tiger 214's frontal hull at the junction of the upper glacis plate. The impact angle was nearly perfect 90 degrees, exactly the condition American engineers at Aberdeen had tested 6 months earlier. The face-hardened steel that had deflected every Allied shell for 17 months did not deflect this one. The tungsten core punched through. A cone of superheated metal fragments sprayed into the crew compartment at supersonic velocity. Keller, the driver, died before he understood what was happening. Bauer caught multiple fragments in his chest and slumped forward over his equipment without a sound. Brenner felt something burning in his left thigh, a piece of armor spalling embedded in the muscle, and the pain didn't register as pain immediately because his mind was locked in a loop trying to process the impossible. The Tiger had been penetrated from the front at 2,000 meters. Out. Everyone out. Now. Training took over where conscious thought had failed. Zimmer abandoned his gun position and moved. Richter, the loader, was already at the hatch. Brenner pulled himself through the commander's cupola, his left leg collapsing under him when he landed on frozen ground. Smoke poured from the open hatches. He looked back at Tiger 214, no fire, but completely knocked out 2 men still inside. And he looked southwest toward Dietrich's Tiger, which had been 400 meters behind, and was now moving forward to engage. Dietrich's gunner fired too quickly. First round short 50 meters in front of the M18's position. Second round struck the hillock directly below the turret close, but the Hellcat remained intact and hull down. Zimmer, lying beside Brenner in a frozen depression, whispered, "He's rushing. He needs to breathe." The observation was correct and completely useless. The M18 fired a second time, from 1,600 meters. The second M93 HVAP round struck Dietrich's Tiger through the turret front, just right of the gun mantlet. The penetration detonated something inside, probably ammunition. The turret hatches blew open simultaneously. Smoke and flame erupted from every opening. No one emerged from Dietrich's Tiger. The explosion had been too fast, too total. 5 men died in approximately 2 seconds. The M18 reversed behind the hillock and disappeared. 14 minutes from first contact to 2 Tigers destroyed. 6 men dead. The entire engagement envelope that German armored doctrine had depended on, for 3 years, had ceased to exist, and no one in German high command knew it yet. When Major Erich Wohlmer arrived at the battalion aid station and questioned Brenner personally, his first response was the same as any experienced panzer officer's would have been skepticism. Not about Brenner's honesty about the ranges. "You're absolutely certain. 2,000 meters for the first penetration. Not 1,200, not 1,500. We ranged properly before the engagement, Herr Major." The M18 was at 2,100 meters, initially approximately 2,000 when it fired. Zimmer confirmed independently. "I watched the muzzle flash through binoculars at the moment of impact." Wohlmer was silent for a long time. Outside the aid station, the preparations for the Ardennes offensive continued, fuel being distributed, ammunition loaded, final maintenance completed on vehicles that would begin rolling in 72 hours. The largest German offensive on the Western Front since 1940 was 3 days away, and the tactical foundation it was built on had just been knocked out by a single American tank destroyer that wasn't supposed to be capable of the shot. If this is accurate, Woolmer finally said, then there is no safe engagement range against American tank destroyer units. Not at any distance where we can see them. That is correct, Herr Major. Which means the Tiger's primary tactical advantage, the ability to engage and destroy threats before those threats can effectively return fire, no longer exists. Brenner nodded. His leg was bandaged. 2 of his crew were dead. He was being asked to think clearly about doctrine while a medical officer had just removed a fragment of his own tank from his thigh muscle. The Tiger can still kill anything at any range, but now they can do the same. Every engagement is mutually lethal. Our crews go into every fight knowing they can die from the front at any distance. Woolmer sent the report to division within the hour. The response came back in 6 hours. Acknowledge forward to Corps, maintain existing tactical posture, pending further assessment. The bureaucratic machinery of German military intelligence, already overwhelmed by the logistical demands of the Ardennes offensive, processed Brenner's report as one data point among thousands. It was noted. It was forwarded. It was not acted upon in any meaningful way before December 16th, when the offensive began. What German intelligence still hadn't grasped, what Brenner's report couldn't fully quantify because he had only seen 2 engagements, was the statistical scope of what the M93 HVAP round represented against Tiger 1 frontal armor at extended range. Post-war analysis would eventually calculate the numbers precisely. At 2,000 yards under the impact conditions of Brenner's engagement, the M93 had approximately 70% probability of penetration against Tiger frontal hull armor. Against the slightly thinner turret front, 85%. These weren't marginal improvements over the previous standard. The previous standard, the M79 AP round, had near zero penetration probability against Tiger frontal armor at that range. The change was not incremental. It was categorical. German technical intelligence finally recovered M93 HVAP shell fragments from multiple destroyed vehicles in late December and sent them to analysts in early January 1945. The tungsten carbide cores were identified definitively. German metallurgists confirmed what American engineers had proven at Aberdeen 6 months earlier. This type of round could penetrate Tiger and Panther frontal armor at ranges exceeding 2,000 meters under proper impact conditions. The analysis was thorough, technically accurate, and arrived approximately 3 weeks too late to affect the outcome of the Ardennes offensive. By the time that analysis reached the units that needed it, Heavy Panzer Battalion 506 had lost 14 Tigers, 6 to enemy fire, 8 to fuel exhaustion and mechanical failure during the collapse of the offensive. No replacements were available. Brenner received command of a Panzer IV, but the tactical shock of December 18th radiated outward from Brenner's engagement in ways that the bureaucratic response couldn't capture. German tank crews talked. The story of 2 Tigers destroyed frontally at 2,000 meters by a single M18 moved through panzer units along the Western Front through December. Some commanders refused to believe it. Others began adjusting instinctively, refusing to hold static positions at extended range against identified tank destroyer units, pressing for faster engagements, trying to keep moving. The psychological damage was significant and impossible to quantify precisely. German crews in Tigers and Panthers had operated for 3 years with a specific kind of confidence, the knowledge that at long range they were effectively untouchable. That confidence had direct tactical value. It allowed deliberate, careful gunnery. It allowed commanders to hold favorable positions without anxiety. It allowed the kind of patient, disciplined engagement that maximized the 88mm gun's advantages. When that confidence eroded, when crews began wondering whether the American tank destroyer in the tree line 2,000 meters away might actually be lining up a killing shot. The quality of German armored operations degraded in ways that never appeared in any official report, but were visible in the increasingly panicked gunnery Zimmer had observed in Dietrich's final engagement. Meanwhile, the American units equipped with M93 HVAP were learning their own lessons about the round's limitations. The tungsten scarcity that had restricted initial distribution remained a hard constraint through the winter of 1944 and into 1945. Even by March 1945, most tank destroyer units carried fewer than 30 HVAP rounds per vehicle, less than half their total ammunition load. Crews developed protocols for identifying priority targets at range Tigers first, then Panthers, then Panzer IVs if HVAP remained. Against lighter German armor, standard ammunition remained adequate and far more abundant. The result was a tactical environment of asymmetric capability that neither side fully understood in real time. American tank destroyer commanders knew they had a weapon that could kill Tigers at extended range, but they carried it in small quantities and couldn't always identify targets accurately enough to know when to use it. German panzer commanders knew something had changed, that the old engagement envelopes no longer held, but couldn't determine which American units carried the improved ammunition and which carried standard rounds. Every engagement against American tank destroyers now carried uncertainty that hadn't existed before August 1944. On December 19th, the day after Brenner's engagement, M18s from the 814th Tank Destroyer Battalion destroyed 3 Tigers from Heavy Panzer Battalion, 301, at ranges between 1,500 and 2,000 meters near Stavelot. On December 22nd, during the fighting near Bastogne, an M18 achieved frontal penetration of a Panther at 2,200 meters a range, at which German doctrine assumed absolute invulnerability. The Panther commander survived and reported to his battalion intelligence officer that the Americans possess a weapon that negates armor advantage at all practical combat ranges. He was right. And what he didn't know, what none of the German officers writing these increasingly alarmed after-action reports knew, was that the Americans were already working on something beyond the M93. The tungsten shortage that limited HVAP distribution had pushed American ordnance engineers toward a second solution. A different approach to the same problem, one that didn't require tungsten at all. And in Part 3, we'll follow that development and its consequences as the Ardennes offensive collapses. German industry begins its final breakdown, and American tank destroyer crews in the Rhineland discover that the weapon they've been using for 6 months has a critical limitation nobody anticipated. A limitation that gets 3 crews killed in a single afternoon near Remagen in February 1945. The metallurgical war wasn't over. It had barely begun. December 18, 1944. 2 Tigers destroyed in 14 minutes. 6 men dead. 1 M18 Hellcat, a vehicle classified as non-survivable against heavy armor, vanished back into the tree line, carrying ammunition that had just rewritten the rules of armored warfare. In Part 1, we watched American engineers at Watertown Arsenal develop the M93 HVAP, round tungsten, carbide core aluminum sabot. 50%, better penetration at every range. In Part 2, we watched that round kill Klaus Brenner's Tiger frontally at 2,000 meters, destroy Dietrich's Tiger 1,600 meters away, and send shockwaves through German high command 3 days before the Ardennes offensive began. German intelligence acknowledged the threat. German bureaucracy filed the reports. Neither response was fast enough to matter. But here's the number that puts everything in context. By January 1945, American tank destroyer units had destroyed 41 Tigers and Panthers using M93 HVAP at ranges exceeding 1,500 meters ranges where those vehicles were supposed to be completely invulnerable. 41 heavy tanks, gone. At distances that German doctrine said were safe. The Germans were finally paying attention, and what they discovered terrified them. German technical intelligence received recovered M93 HVAP fragments from multiple destroyed vehicles in early January 1945. The analysis took 11 days. When the results came back, the conclusion was unambiguous. The tungsten carbide cores had achieved penetrations that conventional steel projectiles were physically incapable of producing at those ranges. The face-hardening process that had made Tiger and Panther armor so effective against standard ammunition was essentially irrelevant against a projectile that maintained structural integrity through impact rather than shattering against the hardened surface layer. The report landed on General der Panzertruppen Hasso von Manteuffel's desk during the final collapse of the Ardennes offensive. He read the penetration statistics twice. At 2,000 meters, 70% probability of frontal hull penetration on a Tiger I. At 1,500 meters, over 90%. He summoned his intelligence officer immediately. How many American units carry this ammunition? We believe all tank destroyer battalions on the Western Front received some allocation, Herr General. Exact quantities unknown. Likely 20 to 40 rounds per vehicle. So every M18 we encounter may be carrying rounds that can kill our Tigers from any practical engagement distance. Yes, Herr General. Von Manteuffel sat with that for a moment. The Ardennes offensive had already failed. Fuel had run out. Allied air power had returned with the clearing weather, and German armored units were fighting rearguard actions across the Eifel region with vehicles they couldn't replace and fuel they couldn't supply. The tungsten ammunition report wasn't a crisis anymore, it was an autopsy finding. He issued new guidance for Tiger and Panther units. Avoid static defensive positions at extended range against identified American tank destroyer units. Prioritize mobility over armor advantage. Engage only when position and approach angle could be controlled. The guidance was technically sound and practically impossible to implement. German units in January 1945 were fighting with critical fuel shortages, no air cover, and overwhelming Allied material superiority on every axis. German armored units began attempting tactical adaptations under impossible conditions. Some commanders tried using terrain aggressively, fighting from defilade, using reverse slope positions, refusing to present frontal targets at extended range. These were reasonable adjustments, but they required fuel to maneuver and time to position two resources German units no longer possessed in adequate quantities. Other commanders simply stopped trusting the Tiger's armor at any range, which degraded the quality of German gunnery as crews rushed shots and abandoned deliberate fire discipline. The psychological damage compounded the physical losses. German tank crews in Tigers and Panthers had spent 3 years operating with the understanding that at long range, they were effectively invincible. That understanding was the foundation of their tactical confidence. When it collapsed, when crews couldn't be certain that the American tank destroyer in the tree line 2 kilometers away wasn't carrying a round that could kill them through the front. The hesitation that replaced confidence was lethal in its own way. But the Germans weren't the only ones with a problem. American tank destroyer units in February 1945 were discovering a limitation of the M93 HVAP round that Aberdeen Proving Ground had noted in testing, but that hadn't received adequate operational emphasis. The tungsten carbide core was extraordinarily sensitive to non-perpendicular impact angles. Against face-hardened armor at oblique angles 30 degrees or more from perpendicular, the M93's penetration advantage shrank dramatically. In some cases, at steep oblique angles, the M93 actually performed worse than standard M79 AP rounds, because the tungsten core's tendency to maintain its shape rather than deforming caused it to deflect rather than bite into angled armor. On February 14, 1945, near Remagen, 3 M18 crews from the 703rd Tank Destroyer Battalion engaged a column of Panthers moving through a valley below their firing position. The angle was steep, approximately 45 degrees from perpendicular. The crews fired M93 HVAP. 6 rounds. 0 penetrations. The Panthers continued moving. 2 M18s were destroyed in the return fire before the platoon could withdraw. The after-action report reached Brigadier General George Rulin at Army Ground Forces Headquarters within 48 hours. 3 crews. 2 vehicles destroyed. 6 HVAP rounds expended without effect at a range and against targets where the M93 was supposed to be decisive. The problem was the angle. The solution was straightforward. Engage from positions that provided near-perpendicular impact angles, not steep overhead positions, but it required training adjustments that hadn't been made because nobody had adequately emphasized the oblique angle limitation during initial distribution. The incident generated internal friction that the official record captured only partially. Some senior officers used the Remagen engagement to argue that HVAP's effectiveness had been overstated, that the tungsten round was a specialist weapon being misapplied. Others argued that the tactical guidance accompanying the ammunition had been inadequate from the beginning. The argument was legitimate, and both sides had a point, which is the kind of internal military disagreement that generates memos, counter-memos, and revised training circulars while men continue dying in the field. The revised guidance reached frontline tank destroyer units by the end of February. Engage from positions providing impact angles within 30 degrees of perpendicular. Do not expend HVAP from steep overhead or highly oblique positions, regardless of range. Conserve HVAP for situations where impact geometry favors penetration. The guidance was sound. It came 6 months after the ammunition was fielded, and by the time it arrived, the engagements that would define the M93's historical legacy had already happened. February 26, 1945. The Roer River Crossing. Near Jülich, Germany. The 705th Tank Destroyer Battalion had been supporting the 82nd Airborne Division's crossing operations for 4 days when German armor counterattacked from the northeast. 7 Panthers and 2 Tigers, moving fast. Objective: reach the Roer crossing point and destroy the temporary bridge that was sustaining 3 American divisions on the eastern bank. If that bridge went down, the Roer crossing stalled. If the Roer crossing stalled, the drive to the Rhine slipped by days or weeks. 7 Panthers and 2 Tigers against a demolished bridge meant potentially thousands of American soldiers cut off on the wrong bank. The M18s of B Company 705th were positioned in a tree line on a low ridge approximately 1,800 meters northeast of the bridge. Captain William Treadwell had 11 vehicles. 44 rounds of M93 HVAP distributed across the platoon, 4 per vehicle. His impact angles from the ridge position were near perpendicular to the approaching German column. The geometry was almost exactly what Aberdeen had demonstrated in June 1944. The Panthers came first, moving at 25 miles per hour across open ground using a shallow valley as partial concealment. Treadwell's first section opened fire at 1,600 meters. The lead Panther took an M93 round through the turret front. The vehicle stopped. Hatches opened. No fire. The crew bailed immediately, recognizing what the penetration meant. The second Panther, following 50 meters behind, tried to turn left into better cover. The turn exposed its flank. 2 M18s fired simultaneously. Both rounds penetrated. The vehicle burned. The third Panther, 1,200 meters now, moving fast, trying to close distance and use its own gun before the M18s could reload. Treadwell's section leader, Sergeant Carl Hooper, tracked the vehicle for 4 seconds and fired. The M93 round struck the glacis plate at near perpendicular angle. Penetration. The Panther slewed right and stopped. 1 crewman emerged from the top hatch and ran. The remaining 4 Panthers stopped, held position at approximately 1,400 meters. Their commanders had just watched 3 vehicles penetrated frontally at ranges where Panther armor was supposed to be invulnerable. They were calculating the same thing Klaus Brenner had calculated on December 18th and arriving at the same terrifying conclusion. There was no safe range. The 2 Tigers came up behind the Panthers. Heavier, slower. Their commanders ordered the Panthers forward, apparently believing that the American fire would shift to the larger targets. The Panthers didn't move. The Panther commanders, watching their platoon mates burn at extended range, refused to advance into fire that was clearly killing them. For 90 seconds, the German column held position at 1,400 meters doing nothing. Treadwell recognized the paralysis for what it was and acted immediately. His remaining M18s repositioned 30 degrees left along the ridge, changing their angle relative to the stopped German vehicles and presenting themselves as moving targets. 3 M18s fired at the Tigers. 2 rounds missed. 1 struck Tiger 1's frontal hull at approximately 1,500 meters. The penetration was clean. The Tiger didn't explode. The round killed the driver and started an internal fire that the crew extinguished, but the vehicle was mission killed. It didn't advance. The German column retreated. All 7 Panthers and both Tigers withdrew northeast, abandoning the counterattack. The bridge survived. The rower crossing continued. Treadwell's after-action report was precise about the numbers: 9 German armored vehicles engaged, 3 Panthers destroyed outright. One Tiger mission killed 4 Panthers, forced to retreat without advancing to effective range. His company expended 22 of its 44 HVAP rounds. 0 M18s lost during the main engagement. The 2 vehicles lost to German fire were hit during the repositioning movement, when they briefly exposed themselves at unfavorable angles, exactly the limitation the revised guidance had warned about. The engagement at the Rower Crossing was not the largest tank battle of the final months of the war. It was not Remagen Bridge itself, not the Ruhr encirclement, not the Rhine crossing operations. But it was a precise documented demonstration of what M93 HVAP could accomplish when used correctly. Proper range, proper geometry-trained crews who understood both the capability and the limitation. News of the engagement moved through American tank destroyer units quickly. Not through official channels, through the informal communication network that exists in every military. The conversations between crews at fuel points and maintenance areas. The stories that traveled faster than official after-action reports. The 705th had stopped 9 German heavies at the Rower, with 11 M18s and 22 H5AP rounds. The math was compelling. The lesson was clear. Tank destroyer effectiveness against German heavy armor increased measurably through March 1945. The combination of accumulated combat experience, better understanding of the M93's angular limitations, and the growing psychological impact on German armored units produced kill ratios against Tigers and Panthers that would have seemed implausible in 1943. German heavy tank units began refusing to engage in situations where American tank destroyers were known to be positioned, a tactical paralysis that had strategic consequences as the Rhine crossings accelerated and Allied armored columns pushed deep into Germany. By April 1945, the tungsten shortage that had limited M93 distribution throughout the fall and winter had been partially offset by production increases and the collapsing German front, which reduced the number of Tigers and Panthers still operational. Many German heavy tanks in the war's final weeks were abandoned for lack of fuel rather than destroyed by enemy fire. Klaus Brenner's Panzer IV ran out of fuel near Magdeburg on April 17th. He destroyed it with hand grenades and surrendered to American forces the following morning. The metallurgical war had ended not with a single decisive moment, but with the slow grinding exhaustion of a nation that had built the most powerful individual tanks in the world and couldn't keep them moving. The Tiger remained technically superior in armor and firepower until Germany's last day of resistance. But superiority means nothing when you can't move, can't fuel, and can't replace what you lose. And the man who pulled the trigger on December 18, 1944, the M18 commander who fired 2 rounds and destroyed 2 Tigers and shattered German armored doctrine in 14 minutes, was never identified. After-action reports from that sector noted multiple successful M18 engagements by units of the 705th Tank Destroyer Battalion. No specific crew was recorded for either kill. He fired 2 shots, changed the course of armored warfare, and walked away anonymous. But here is the question that Part 4 will answer, the question that historians spent decades debating after the war ended. The M93 HVAP round proved that technological surprise could overturn 3 years of established battlefield reality in a single engagement. The tungsten-core that defeated Tiger armor at 2,000 meters was a secret weapon that worked. So why didn't the Americans use it sooner? Why did it take until August 1944, 3 years into the war, to field a round that Aberdeen's engineers had theorized was possible much earlier? The answer involves a decision made in 1942 that almost lost the war in Europe. A decision made by men who were right about everything except the one thing that mattered most. That story, the full story, is waiting in Part 4. Over 4 parts and 70 minutes, we've followed a story that began with a single impossible shot on a frozen hillside in eastern France. Part 1 showed us the metallurgical revolution. Tungsten carbide cores, aluminum sabots. 50% better. Penetration at every range. Part 2 watched that revolution kill 2 Tigers in 14 minutes and shatter German armored doctrine 3 days before the largest German offensive on the Western Front. Part 3 showed us the Roer River crossing, where 11 M18s stopped 9 German heavies and saved a bridge that 3 American divisions depended on. But Part 3 ended with a question that the combat record alone can't answer. The M93 HVAP round worked. It worked decisively repeatedly at ranges German doctrine classified as invulnerable. So why did it take until August 1944, 3 full years into American involvement in the war, to field a weapon that Aberdeen's engineers had theorized was possible much earlier? The answer involves a decision made in 1942, and the man at the center of that decision never received a single medal for the role he played in ending the war in Europe. His name was Dr. Lawrence Thompson. Not a soldier, not a general, a metallurgist from Pittsburgh who had spent the 1930s developing tungsten carbide tooling for the American machine tool industry, the cutting bits and drill heads that American factories used to manufacture everything from automobile engines to refrigerator components. Thompson understood tungsten carbide the way a musician understands an instrument, not just its properties on paper, but its behavior under stress, its failure modes, its unexpected capabilities when pushed beyond designed parameters. Thompson joined the Army's Ordnance Department as a civilian technical consultant in March 1942, 3 months after Pearl Harbor. He was 41 years old, slightly overweight, wore glasses with thick frames, and had never fired a military weapon in his life. His job was to advise on material procurement for conventional armor-piercing ammunition, hardened steel cores, standard production, nothing exotic. He was by every institutional measure a background figure, a technical advisor. Someone who wrote reports that other people summarized for the officers who made decisions. Within 6 months of arriving, Thompson had written a report arguing that conventional hardened steel cores were fundamentally inadequate against the face-hardened armor that German engineers had developed for the Tiger and Panther programs. The face-hardening process specifically exploited the shattering tendency of conventional projectiles. You couldn't solve that problem by making the steel harder. You solved it by using a material that maintained structural integrity through impact. Tungsten carbide. The same material Thompson had spent a decade working with in industrial applications. The report went to Colonel James Dalton, chief of the Armor-Piercing Ammunition Section at Army Ordnance. Dalton read it, acknowledged the technical argument, and declined to pursue it for reasons that seemed entirely reasonable in 1942. Tungsten was a strategic material. American industry needed tungsten for machine tooling to produce the weapons, vehicles, and equipment that the war required. Diverting tungsten into ammunition production would reduce the machining capacity that manufactured everything else. The trade-off wasn't obviously worth making when American forces hadn't yet encountered Tiger or Panther armor in significant numbers. Thompson disagreed. He argued that the trade-off calculation would look completely different once American armor met German heavy tanks in sustained combat, that the penetration failure of conventional ammunition against Tiger frontal armor at extended range would produce casualty rates that made the tungsten diversion economically and strategically justified. Dalton acknowledged the argument and maintained his position. Development of tungsten-core ammunition was assigned low priority. Thompson spent 18 months in bureaucratic frustration that the official record captures only partially. He continued writing reports. He requested small-scale prototype production for testing. He found allies in the lower ranks of the Ordnance Department junior engineers who understood the technical argument and helped him develop preliminary designs for what would eventually become the M93. None of this moved fast enough to matter in North Africa or Sicily or even the early months of the Italian campaign, because German heavy armor hadn't yet appeared in the combinations that made Thompson's argument undeniable. Tunisia changed things incrementally. Kasserine Pass. February 1943. American armor encountering German tank gunnery at ranges where return fire was ineffective generated after-action reports that supported Thompson's penetration concerns, without specifically validating his tungsten solution. The institutional response was to develop the 76mm M1 gun, the higher velocity barrel that improved penetration with conventional ammunition. This was the solution that Dalton and the mainstream ordnance establishment preferred: better conventional ammunition rather than exotic tungsten cores. The 76mm improvement was real and significant against medium German armor. Against Tiger frontal armor at extended range, it was inadequate, and Thompson said so in writing in November 1943 and again in March 1944. By then, the Normandy invasion was 3 months away, and the production pipeline for conventional ammunition was running at full capacity. Disrupting that pipeline for tungsten-core rounds remained institutionally unpalatable. What finally moved the decision was not Thompson's reports. It was a single combat evaluation conducted at Aberdeen Proving Ground in April 1944, 2 months before D-Day, in which a captured Tiger I was engaged by 76mm guns at various ranges, using both conventional M79 AP and a small batch of experimental tungsten-core rounds that Thompson's team had produced with informal support from several sympathetic engineers. The conventional rounds failed to penetrate at 1,400 meters. The tungsten rounds penetrated at 1,800. The evaluators watched the results in silence. The decision to develop and produce the M93 HVAP round was approved within 3 weeks of that evaluation. Thompson was credited as the technical lead on the project. Production began in June 1944. The first rounds reached frontline units in August. By December, Klaus Brenner's Tiger was dead at 2,000 meters. Thompson never received a military decoration. The Ordnance Department's internal recognition for the M93 development project went to the officers who managed procurement and production. Thompson received a written commendation and a modest civilian bonus. He returned to Pittsburgh in September 1945 and went back to industrial consulting. In a 1963 interview with the Army's Historical Division, declassified in 1987 and largely ignored by mainstream military history, Thompson was asked whether he felt recognized for his contribution. His answer was precise and characteristically undramatic. "The round worked. That's what mattered. The men who used it are the ones who deserve recognition. I just figured out the material." He died in 1971. His obituary in the Pittsburgh Post-Gazette mentioned his work in the machine tool industry. It did not mention the M93. The technical legacy Thompson left behind outlasted him by decades. The principle he applied that face-hardened armor requires a projectile that maintains structural integrity through impact, rather than a projectile that simply carries more kinetic energy, became the foundational concept for armor-piercing ammunition development in every major military for the next half-century. The tungsten core evolved. The sabot design improved. The materials science grew more sophisticated. But the core insight remained constant. During the Korean War, American forces encountered Soviet-supplied T-34 tanks equipped with improved armor that conventional 76mm rounds struggled to penetrate reliably. The solution was a refined version of the HVAP concept, improved tungsten cores, better sabot design, higher velocities. The M93's intellectual lineage was direct and unmistakable to anyone who understood the engineering. In Vietnam, armor-piercing rounds used by helicopter gunships and tank destroyers against hardened targets incorporated sabot designs that descended in a clear line from the aluminum sabot Thompson's team had developed for the M93 in 1944. By 1980-12, NATO nations had adopted armor-piercing fin-stabilized discarding sabot rounds, APFSDS, that represented the mature evolution of exactly the principle Thompson had argued for in his 1942 report. The tungsten core had been optimized into a long rod penetrator, the sabot refined into a 3-pedal design that shed cleanly at the muzzle, the velocities pushed beyond anything Aberdeen's 1944 tests had contemplated. The M93 was a direct ancestor of the ammunition that American M1 Abrams tanks used to destroy Iraqi T-72s in the Gulf War of 1991 engagements, where American armor killed Iraqi vehicles at ranges and from angles that should have been safe in engagements that lasted minutes rather than hours against opponents who had no answer for the penetration capability being used against them. The pattern was identical to December 18, 1944, scaled up and made more precise by 47 years of development. The byhook, the lesson that the M93's development and deployment teaches, is not primarily technical. The technical details are impressive and historically significant, but the deeper pattern is about the relationship between institutional inertia and individual insight under conditions of genuine uncertainty. Colonel Dalton was not wrong in 1942 to be cautious about tungsten diversion. His reasoning was legitimate given the information available at the time. The mistake was not his initial caution. It was the institutional tendency to treat that initial caution as a settled conclusion, rather than an ongoing assessment that should be revised as new information arrived. Thompson continued producing new information combat reports. Penetration failures captured armor analysis, and the institutional response was to note the information and maintain the existing position. This is not unique to the Army Ordnance Department in 1942. It is what institutions do. The structure that makes large organizations capable of coordinating complex activities across thousands of people is the same structure that makes them slow to incorporate insights that challenge current practice. The men who overcame that inertia were not rebels or revolutionaries. Thompson worked within the system, wrote reports through proper channels, built informal alliances with sympathetic engineers, and waited for a demonstration that would make the institutional cost of continued inaction higher than the institutional cost of change. The Aberdeen evaluation in April 1944 was that demonstration. The system then moved quickly, 3 weeks from evaluation to production approval, 2 months from approval to first deliveries, 4 months from first deliveries to combat use at Normandy. The same institutional machinery that had resisted the idea for 18 months executed it efficiently once the decision was made. There is a final detail about the M93's story that remained classified until 1989, and that most histories of World War II armored warfare still don't mention. The Aberdeen evaluation in April 1944, the demonstration that finally moved the Ordnance Department to approve production, was not conducted with Thompson's authorization. He had been formally told in February 1944 that further prototype testing was suspended pending budget review. The small batch of tungsten-core rounds used in the April evaluation was produced using materials and machining time that Thompson had quietly arranged through informal channels with 2 engineers at Aberdeen, who believed in the project and were willing to work on it without official authorization. In contemporary terms, Thompson ran an unauthorized research program inside a government facility using government resources for 4 months, produced prototype ammunition without production authorization, and arranged for that ammunition to be included in a formal evaluation without disclosing how it had been manufactured. When this was discovered after the April evaluation, the discovery was buried by the same officers who had just approved production, because the alternative was to acknowledge that the ammunition that might win the war had been developed through a process that violated approximately a dozen procurement regulations. Thompson was never disciplined. The paper trail was quietly amended. The official history of M93 development describes a continuous, properly authorized research program. The 1989 declassification revealed the gap between that official history and what actually happened in the machine shops at Aberdeen during those 4 months. Thompson knew exactly what he was risking. He risked his career, his security clearance, and potentially his freedom to produce 37 prototype rounds that he believed would save lives his institution wasn't moving fast enough to save. He was right about the rounds. He was right about the timeline. And he received a written commendation and a modest bonus returned to Pittsburgh, and worked in industrial consulting until he died without his obituary mentioning any of it. From a machine tool consultant with an unauthorized prototype and a report Nobody wanted to read to a fundamental shift in armored warfare that shaped ammunition design for the next 80 years. Lawrence Thompson proved that the most important innovations rarely come from the people with the authority to implement them. They come from the people who understand the problem clearly enough to act before they have permission. The M93 HVAP round was fired in combat approximately 74,000 times during the final year of the war in Europe. Post-war analysis attributed between 800 and 1,200 German heavy tank kills. Tigers, Panthers, and equivalent vehicles to HVAP ammunition at ranges where conventional rounds would have failed to penetrate. The tungsten core that Thompson's team designed in a Pittsburgh office and refined in an unauthorized Aberdeen machine shop was responsible for engagements that shortened the European war by a margin that military historians still debate but universally acknowledge as significant. The unnamed M18 commander, who fired 2 rounds on December 18, 1944, and destroyed 2 Tigers at 2,000 meters, was the end of a chain that began with a metallurgist writing reports that nobody read. Both men did their jobs precisely and completely. Neither received adequate recognition. Both changed the war. That is why this story is worth telling. Not because technological innovation wins wars, it doesn't alone ever, but because the distance between an idea that could save lives and the decision to act on it is almost always shorter than the institutions standing between them make it appear. Thompson crossed that distance with 37 unauthorized prototype rounds and the willingness to be wrong in front of people with the power to end his career. He was not wrong, and the Tiger burned at 2,000 meters.